very warm welcome, and let me first introduce you very briefly to wega. Probably many of you have been in touch with wega before or know wega. We are a service provider who specializes in building the bridge between business and IT, and actually tries to connect these two worlds in laboratories, in life science, in the life science scientific domain, where you do need a lot of informatics solutions, but also you do need to have a very good understanding of the business processes and what's actually going on in life science, from early research up to clinical and also QC and laboratories, etc. And wega has been growing over the past couple of years quite significantly, and we are very proud that in the meantime we are a bit more than 100 employees who actually focus around the services that are depicted here. So the two domain areas from, as I said before, from early research, lab and research informatics to clinical development informatics and everything that goes along with that. So any informatics solutions you're actually using in these domains. And the two domain networks are accompanied by two additional networks around computer system validation and quality assurance and informatics solutions. As you can imagine, that depending on the space where you're in, if you are in a regulated environment, then of course you do need computer system validation services alongside your project. But of course you also need to have a lot of domain expertise and domain knowledge, and you need to combine the skills from based on our experience in order to arrive at a successful project, which in the end, most importantly, I believe, should have an end user in mind, and therefore combining interdisciplinary skills has been proven to be very vital for our projects. If you want to know more about wega, feel free to reach out to us or go to the wega website. But I don't want to make it too long about wega, because we're here because of Andy and his presentation. And I just wanted to notify you briefly for upcoming events. There will be another virtual Smart Lab Connects on September 7 and 8. I think registration is free for everybody. It's a virtual conference type of event, and we will have another session around how a digitalized lab should look and feel like. This is an inspiration talk that is based around how you can successfully digitalize a lab and what you have to look at, starting from technical aspects, using standards, up to actually user experience aspects. So you're very welcome to join that one. On October 4 and 5, there will be a hybrid event effectively. So it's possible to have a physical presence, to go there. I think it's a bit half-half. So half of the speakers are physically present and half of it are virtual, or half of them are virtual. And it is the Society of Lab Automation who actually organizes the European Sample Management Symposium, again, as the years before in Berlin. And we will be present as well, and having a session about how blockchain technology can be used in the sample management domain. And that's going to be an interesting presentation. So, and you're very much welcome to go there. And this is not a free event, but I think it's at a reasonable price. And then, as every year, we'll be present at the LIMS Forum. It's not yet 100% sure whether this will be a live physical on-site event or whether it will be virtual only. I think this will become clearer tomorrow, actually, and you can check that on our website, on the website of the LIMS Forum. Okay, then today, what do we offer for breakfast? I think I said that at the very beginning when not everybody was here in that unfortunately we again have to do it in a virtual way. But fortunately, this allows us to actually include many more interesting participants, I think, to this presentation, because probably not everybody of you could travel to Basel, where these events are usually taking place. So, and I'm really very, very happy to have Andy Mitchell from Unilever today with us. Andy will talk about his journey around automation and standardization at Unilever. Andy has a very impressive career. He actually started working for Unilever already in 1995 as a microbiologist. And there he started actually with performing European Disinfectant Tests. And this is a very laborious and resource-intensive manual assay. And therefore, he soon started to develop a miniaturized version that fitted into microplates and that enabled actually the automation through liquid handling platforms and robots. And following on in that journey, he was then a founding member of the R&D high throughput sciences team at Unilever, and whereon he has spent 15 years building platforms, automation platforms, particularly focusing on data management standards and IT infrastructure topics. And the purpose actually of that was that any data point that is generated should be available for decision making, and wherever and whenever it's needed in the organization. And in this session here, Andy will discuss his journey, what has changed along this long time and what has also stayed the same. And Unilever, I think, has moved away from single instruments through large integrated platforms, and now they're going into the world of collaborative robots. And I'm very much looking forward, Andy, to your presentation, and I would like to hand you over. And a very warm welcome again to you, and thank you, Andy, for sharing your journey today. Thank you. The stage is yours. I'm just unshare my screen.
You're still muted, Andy.
I'll say thank you again for the opportunity to speak. Is my screen sharing? Is my screen sharing now?
Perfect. Yes, we can see you.
Can everybody hear me?
Yes.
Okay. So yeah, I'm Andy Mitchell. I'm now a data manager at Unilever. As Daniel said, I've had a career spanning 25 years, which I'd like to talk about today. Initially, I'll just start with a quick overview of Unilever and then what I've done and what we're planning to do in the future. It'll take me about an hour. So Unilever is one of the largest consumer goods companies in the world. We're driven by our purpose to make sustainable living commonplace. The company is over 100 years old, and its founder, William Lever's purpose was to make hygiene commonplace. So back in Victorian Britain, he launched Sunlight Soap to help tackle infectious diseases. And we've been working on the same purpose pretty much the whole time. So Unilever is a truly global business. We now believe 2.5 billion people use our products every day. When I first did this presentation, it said 1 billion. So it's growing rapidly. We sell products to 190 companies, 190 countries, many of which we've been in for most of our 100 years. So places like India, Indonesia, Argentina. Turnover was just over 50 billion last year. We have a network of around 25 million distributors who serve our 3 billion consumers. The company is split into 3 pillars. So we have a beauty and personal care division, foods and refreshment division, and home care division. Most of what I'm talking about, I've been working in home care most of my career, although I work cross division with beauty and personal care and a little bit with foods and refreshments. Hopefully you recognize some of our brands. We make many of the world's favorite brands. Many of these are £1 billion businesses in their own right. In terms of R&D, we've got 6 research sites around the world and many distribution centres and market centres. The 6 big sites are Trumbull in the US, and then Port Sunlight and Colworth in the UK, Wageningen, which is our new site in the Netherlands, and then Shanghai and Bangalore. Spend is around 800 million a year with 5,000 professionals in the business. So on to me. I've called this talk Standardisation and Automation. However, for most of my career, we were talking about high throughput. So I just wanted to put a definition of what high throughput was, or is to us. This comes from the Insight Faraday report, which right at the start of the high throughput journey, my boss was actually on sabbatical to the Insight Faraday group to travel the world and understand what opportunities high throughput technologies could bring to our businesses and the other businesses in the partnership. So the sorts of things that they identified: automation, miniaturization, parallelization, combinatorial chemistry, parallel synthesis, high throughput screening, rapid continuous processing, effective design of experiment, complex data visualization, interpretation, modeling, and in silico screening. So I think I'll cover 80% of those in this talk on how I was involved in them. So as Daniel said, I started at Unilever on the 9th of May 1995 as a fresh-faced graduated microbiologist. And my first job was in the household products hygiene section, where I needed to prove that Domestos killed all known germs. Anyone that was in the UK at the time will probably remember the Domestos adverts, which were "kills all known germs dead." It was a very powerful message. To be able to back that up, we needed to pass a standard in the European market, which was called the European Suspension Test. And this is my colleague Karen doing the start of our miniaturized test. If we look at the original test, it involved putting a mil of your formulation into 10 mil tubes, and then serially diluting them down, mixing each of your serial dilutions with agar, putting them into petri dishes and counting them. This was very time consuming, very slow, very expensive. And one of my first jobs was to look at making a screening tool that was more efficient than doing the full test. We always had to do the full test to get a product on market, but we only wanted to do it once, not on every possible formulation we wanted to test. So the first thing we did was move from 10 mil to 300 microliters, which meant we could fit in a petri dish, into a microplate. Then we moved from a solid media to a liquid growth medium. Now we could start using the multi-channel pipettes to do the whole assay. And we got a 12-fold throughput just by having a 12-channel pipette. Overall, we improved the throughput of the experiment by 100-fold. And we could also now read the plates in a standard plate reader. This enabled the development of the minimum disinfection concentration protocol, which was all liquid, all based in a microplate, and that allowed us to move on to using automation and full factorial designs. So my first platform, just looking at the time on that clock, 2003. That's actually a very late photo of that robot. This is a Tecan Genesis platform that we got a lot of equipment on the deck. So we had a liquid handling arm with 8 fixed tips. We had a roamer arm, a robotic manipulator arm, which could move plates around, both big plates, deep well plates, as well as the normal 96 well microplates. We had a plate reader tucked onto the back of the deck. Next to that, we had a incubator. Then we had a couple of storage racks for deep well plates and normal plates. And on the right-hand side, we have this swap arm, and you can possibly see at the front the carriers. So we had another 100 plates off the deck. We also had customized racks on the deck. There's actually a ruler there with a block stuck on top, which we used to put over the top of this cooled rack to keep the bacteria, well, try and stop them getting contaminated and keep them cool. And there was a customized rack built for the 10 mil tubes, the normal racks for microplates, where we actually did the assays. There's also, as you can see, a webcam on the deck, so we could actually watch this robot running remotely. I think this is the first webcam we had on site. We were running Windows NT. I don't know if anyone remembers back that far. It didn't have USB. So actually connecting up any device was a challenge, and getting the serial, all the serial ports set up for this was a continuous challenge. While we were successful in doing microbiocidal assays on the deck, trying to keep 8 fixed tips decontaminated when you were picking bugs up with them proved to be not the best idea. So we moved on to assays that use dyes rather than microbiological samples. In this case, we were looking to prevent malodor, which you can do by inhibiting the CS lyase enzyme. And the dye shows up whether the enzyme has been deactivated or not. And within 2 months, we were able to screen more than 8,000 tripeptides using the TCAM platform and our early data management systems, which I'll talk about later. Also at this time, I moved to the hard surface cleaning platform, and I just picked a few slides from a presentation I gave at the European Laboratory Robotics Interest Group back in 2003. So while we'd got computers starting to come into the lab, they were very big. Most of our bench space wasn't set up to have computers on it. So we were looking to use the Hewlett-Packard H2210 personal digital assistant to help us with electronic data capture. We chose this device because it had it was Microsoft operating system, which allowed us to connect it directly to our PCs. And it also had Pocket Excel on it, which meant scientists who were in a world that they loved, and they could collect data onto templates on the PDA and transfer it seamlessly to their computers. It also had serial support, which meant we could plug it directly into a balance, and it had an SDIO slot, so we could put a barcode scanner into the top of the PDA. We had early success with an experiment that I was doing regularly at the time, which is where we took a stainless steel tiles, we put some oily soil onto them, we'd weigh them, we'd then clean it using one of our products, rinse it and reweigh it to see how much of the product we'd removed. Doing this manually, you'd press the print button or you'd press the tear button on the printer, put your tile on, wait for the balance to stabilize, write down the weight in a notebook, then go back to your desk and type it in. By plugging the PDA directly into the balance, we were able to put the tile on, press the print button. As soon as the balance had tared internally, it would send the weight to the PDA, and then you could take the tile off and do the next one. We'd set up a template so the results went into the right place. And for each round of weighing, we reduced the time from 90 minutes to around 15 minutes. And all the transcription errors of going from writing into a notepad and typing it back into your computer. We also found that we could actually go beyond what was being done in the lab currently. Again, there's very constrained bench space here, so we couldn't plug a computer into this particular balance, but we wanted to do an evaporation profile of this cloth drying. So we were able to use a different piece of software, CE Wedge, to take a weight off the balance every 30 seconds directly into Excel, and then again we could sync the PDA to our desktop and plot the evaporation curve. So early success with electronic data capture and moving beyond the paradigm that was possible with regular bench work. I mentioned people factors. So we had an initial cohort that was myself and some early adopter colleagues. We were very quick to adapt to the PDA, and we started using it for many other things. It became our sort of go-to tool. However, getting that into the wider group was a lot more challenging. Many people were, well, I've been doing this experiment for the last 10 years. Why should I listen to this young upstart that's come into the group? I'm going to keep doing it my way. I don't have time to test new methods. I've got all this work that I need to get through. All that screen's too small. Some people just didn't like technology. And it had an effect on the way they did their workflow. So because we'd set the template up, you had to get everything organized before you started the experiment to make sure that the tiles you weighed put the results into the right boxes. So while we got the weighing, I saw we're having a lab, we're moving labs at the moment, and I saw some of those PDAs coming out of a drawer with chargers. So batteries have long died, but the people that first adopted it are still using it almost 15 years later. So we saw the PDAs spread with the people. The early adopters took them with them to new places, but other people didn't really adopt them. So what are my observations from my first 10 years in Unilever? Well, we made huge productivity gains by rethinking assays and workflows. I put corporate IT there. any IT is challenging when working with robots and automation and electronic devices in a laboratory space. Certainly possible to do electronic data capture, but we did need an expert team, both in the science and sort of IT technology, to maintain it. Just because it's technically possible doesn't mean it's necessary to do or right thing to do. One of the things we did with the PDAs, we got a serial to Bluetooth connector. So we had a serial to Bluetooth dongle on the balance. We had the Bluetooth working in the PDA. It was incredibly difficult to get the settings aligned at that time, and it was a lot quicker and easier to do with a simple cable that worked perfectly well in that setting. So we pushed the limits and came back to what was sensible. Around this time, we were working on mainly miniaturization and parallelization. Talked a bit about design of experiment. The other things came later in the career. It was very grassroots, so we had minimal management oversight. It was a few £100 to buy the PDAs, but people and change management were key factors. And with grassroots, as I say, it spread to early adopters, but not much further. Commissioning platforms takes years. Getting that TCAN to do a disinfectancy assay without cross-contaminating samples took about 18 months. So it was very challenging, even with all off-the-shelf equipment. So the scale up, sort of the next 10 years, 2005 to 2015, Unilever had launched the Unilever Sustainable Living Plan. So we had to reformulate the portfolio that had been made probably over the last 30 years in around 10 years. And traditional bench science wasn't going to help us do that. So we moved to a mix of automation and computation. So our high throughput lab didn't really look like the traditional lab in the building at the time. Lots of benches, lots of different types of glassware. And actually that laboratory doesn't look too different to the very first laboratory that Unilever opened in Port Sunlight over 100 years ago. Now our laboratory is no benches, it's robots, it's computers. The robot I've got in the video here is our hard surface cleaning robot. So it's got two arms on it. The first arm in the top left is used to scan barcodes, pick up samples, and move the plates around. The second, which is on the top right, which of course just gone out of shot, has a force transducer on it. I've lost my. There's a force transducer on it. I've lost my. Can you see my my laser pointer?
We see a mouse pointer.
Okay. So we have a force transducer there, and then the force transducer picks up a piece of fabric and it pushes down onto the surface with a consistent force, which is obviously far more reproducible than a human trying to do this this assay. And it can do around 100 tiles per night. So you see in the top right there, it's doing a cleaning now. So it's pushing down with a consistent force, does a consistent number of strokes. Then we image and analyze that plate to find out how much soil we cleaned off. So bigger. In this example, we were looking at making deodorant more gentle on skin. By using the Formax platform and design of experiment, we were able to explore 40 times more formulation space than our colleagues working on the bench. We also believe we did it better. So we have moved from personal paper records to our experiment management system. At this point, there were 500 million results in that system. I'll talk about that a little more later. And we were also moving from large-scale washing machine assays where fabric swatches were 0.5 meter by 0.5 meter into microplates. So the robot on the right here is our Lisa Marie robot. It was called Lisa Marie because the original robot was called Elvis, and it moved and shook microplates. So on the bottom left, there's an incubator shaker. We put the fabric discs into the microplate. We scan them on this scanner. We put our laundry formulation into the vials. We put it into the incubator where it gets shaken and mimics a wash cycle. We then rinse the plate, dry it, put it back on the scanner, and look at the LAB value, so the change in color on that fabric. Lisa Marie could easily do 100 washing machine days in just 2 days of operation, and is still running today. So I've talked a bit about data management and common interface. The vision, as Daniel said at the start, was to ensure that every data point we had was presented to a scientist in a state that they could make a decision on. So all the data manipulation had been done before they received it, and wherever they were in the world and at whatever point they needed to use it. So we have a virtuous cycle, which I suspect many people recognize. First, we need to define the experiment we want to do. We then need to go and either source or synthesize the materials, make them into a formulation with specific processing, characterize our formulation or product to make sure it's what we're expecting, and then do a performance evaluation, which is taking that product and using it in a relevant scenario. So this might be a shampoo being tested against a hair switch, or a hard surface cleaner being tested against a kitchen worktop. We then get all those results into our common data management system, where we can then do informatics, data mining, visualization, interpretation of those results to help define the next iteration of the assay, with products constantly coming out. I have a vision of 2 strands to scientific data. So the first strand is agnostic. It's the fundamental molecular building blocks, which are the same across all experiments. As I said, those get put together to make a product, and that product needs to be registered and understood how it was made. And then it's used to do performance measurements and give us measured data. That data can then be standardized and put into a data store, which makes it available for modeling. At the same time, a scientist did that experiment for a purpose at that particular time. So we used the electronic lab notebook, which is effectively, in our case, a paper on glass lab notebook, for recording what was done at each of these stages and what it meant in the context of the project it was being done for. So this is where the business insight is gained in the moment. This is where we store all the underlying and underpinning data to enable reuse later. I was specifically interested in the registration and the measured data space, and we built a suite of tools around that for high throughput. The first one was our flow registration system. So it has a user interface where users could manually enter information or search and pull information from the system. More importantly, it had an API that was available or is available on the internet, so robots could interact with the system as well as informatics systems. The types of things we registered, we start with an abstract concept such as materials, say sugar. When you get a bottle of sugar in your kitchen, we can start adding extra metadata to it. So it now has a supplier, it has a location, that location can move so we can track it. It has a physical form, whether it's soluble sugar or granular sugar. We have a quantity that can potentially be deprecated as that product's used. And then we can start mixing those materials lots together. So if we make a sort of wet and chemically product type thing, we have a formulation. We can build that from a formulation template, such as a standard shampoo. We've got extra information coming in now. We've got the amounts that were added, the specific lots that were added, the processing conditions they were added under. We've also mentioned substrate. So these are normally the things performance measurements are done on. So for example, that stainless steel tile, we started with a stainless steel tile. It went through a cleaning process. It went through a soiling process with an oil being added with carbon black to visualize the oil. It was heated. It was stored for a certain amount of time. All of that is recorded as a substrate before the product is added to that substrate, where we get a performance measurement result. At that point, we move from our registration system to our results collection system. This is called the experiment management system. Again, it has a user front end, and it also has an API to allow it to interact with the robots. Very early, we found that trying to lean on pharma LIMS systems wasn't really working for us, because they were all focused on the active as the thing that the results were held against. For us, with the laundry formulation, we could have the enzyme would be the active one day, the surfactant might be the active the next day. So we built the EMS with the location as the place that the results were held, and I believe that's quite unique. So whatever we put into that well, all these Smarties are dragged across and dropped onto the well, and then the results are held against that location. They could be multi-dimensional results, so we could have time series data being held, we could have attachments being held, we could have data being appended at multiple time points for stability studies. It's proved very, very robust for all the experiments we've been doing since 2003. Well, we've got that very stable system that hasn't really changed. R&D is very dynamic. So we use Pipeline Pilot as an integration layer, which means that we can pull the data from various systems. We can do manipulations, either very simple manipulations such as an average or pivoting the data, all the way through to quite complex modeling software, and Python and R are built into the tool as a component, so we can use those scripts as well. The green boxes are visualization components, so we can visualize as a simple PDF report, as you saw earlier, which is a standard report for every experiment. A lot of the stuff we do now are interactive web pages, so scientists can start making decisions on the data within the Pipeline Pilot tools that we present. One of the things with automation is that you're not standing there watching your experiment happen. So we need to have tools to help us understand the health of our robots. And my colleague Mart Orty wrote us the reliability, utilization, and failures log. So at this time we were using Tweet.io, which is like tweets. So our robots were tweeting their status periodically. And then we had this board showing in the main office in our laboratory. So you could see if everything was green, everything was good. You could see if your experiment was about to finish and it was worth going back down to the high throughput laboratory. And if it was red, you could see that there was an error. The rough log was also available via push bullet, so you could scan this 2D barcode, and that would allow you to track your experiment on your phone wherever you were in the building. We used Trello as our tracker for issues. We'd stopped trying to use the corporate IT tools because they were designed for corporate IT systems, and it was much easier to have something fast and light for ourselves. And we also used TeamViewer to access those PCs. So along with the webcams, if we could see that it was something we could fix remotely, then we could TeamViewer it onto the computer running the robot and press retry or reset or whatever was needed to keep the run going. I've mentioned culture change a couple of times. We've now got much bigger platforms, but we've seen a much bigger change in the way scientists interact. And in one particular case with stability testing, but obviously every product we make has to be tested that it's going to last in the consumer's cupboard for the time that we say it will. Traditionally, this would be lots of scientists sitting at individual rheometers taking measurements. And we built an automated stability platform. And very quickly, the group reorganized itself because we now had a data management system that had everybody's samples that needed to be run that day listed. And they were able to just have one person loading the robot each morning while everyone else was preparing new formulations and preparing new assays. So we freed up a huge amount of time for doing science rather than just finding vials and bottles in an oven and moving them to individual rheometer stations. More importantly, we standardize this across multiple, not just multiple divisions, but multiple groups as well. Or sorry, not multiple groups, but multiple divisions as well, which caused cross-department working, which hadn't really been happening at this stage, to become the norm. So if one robot was down or one robot had too much capacity and one was overused, we could move the samples around the laboratory very seamlessly because the data management system was actually listing all the division samples, not just in individual groups if you press the right buttons. And this was a bottom-up change, so that the group self-organized based on the automation they've been presented with. And also, as I said, the data management was now centralized, so there were no more personal spreadsheets and everyone could see what was going on very clearly. While we were building the platforms I've shown you, which I'd call integrated platforms, so they had instruments you can buy off the shelf, such as the Tecan Genesis platform, the ChemSpeed platform. We were also beginning to build more bespoke robots. So these were the standardization layer was more at the Festo pistons and that type of thing rather than full instruments. These took a long time to build and are very complicated. So we need to define the project. We need to define our user requirement specification. Once that's locked, this had never been done before. So we need to do design studies to be confident that the full platform would work. Then we had to choose someone to build it. We had to get through the Unilever capital process, place the order. Then the supplier needed to do the functional design specification, which we needed to sign off before they actually built as a platform. Then the fun would start with going down to their factories and trying to do our factory acceptance testing to prove that the robot was doing what we needed it to. This would be a very iterative process. I don't think we've ever passed a FAT on the first, second, possibly we've done one on the third attempt. Then it comes to site, gets installed in situ. We have to ensure again it's doing the assays that we really want to do now, and hand it over to the team. So we're looking at easily 2 years to get a big platform into the building. We have multiple people working on it, multiple teams. So we had some engineering design principles to try and help us build these platforms in a consistent way. For me, the key one was that the data management was consistent across all the platforms. So we had the same API commands going in and out. We tried to build them in a modular way so that they were simpler to use and understand. We made the decks upgradable, so wherever possible, we left extra space on the deck and extra connectivity points for both hardware and software so that we could add new instruments. Keeping it maintainable, at this stage we had an expert team, so we'd do quite a lot of maintenance ourselves. But ideally we wanted the system to be reliable so it didn't actually didn't fail. I mean, these were one-off systems, so very much taking a proof of concept car and trying to use it as a motorway for tens of years. So they need a lot of TLC to keep them running. They needed to be usable. We were putting these huge robots in the hands of scientists that were used to bench science. So making it as user-friendly as possible would help them get the assay onto the platform right first time, and not be scared of it. We also had many different assays running on these platforms. We designed them to be flexible, so they needed to be cleanable and easy to change over. But we look at the early platforms that we built. First one was our formulation processing module that had a conveyor belt system going around an L shape. This had automated dosing of liquids, powders, and viscous materials, had heat and various impellers on it, had a rheometer and pH adjust. We were using it to make thick bleach, liquid abrasive cleaners, toothpaste, that type of thing. Very challenging platform. First time we tried to do this, and we learned a lot. Second platform was shown here is the friction rig. So this platform actually had an early win when Unilever, excuse me, launched its Comfort Easy Iron, and we were able to prove with this platform across a huge range of samples that actually Easy Iron really did make the iron glide more easily. It was unique at the time because this was a truly cross-group, cross-division platform. So we had stakeholders from fabric conditioners for the iron glide. We had laundry samples looking at fabric softness. We had hair with hair conditioners, and we also had oral care looking at mouthfeel. So very versatile platform. As I said, we learned a lot with our first formulation processing platform. Our next round of investment was in the Formax, which I showed earlier on the on the DO presentation. Again, the Formaxes were great for what they did, but we pushed the boundaries and found areas that it couldn't really work. So we had a very ambitious idea, which we couldn't really justify within Unilever ourselves, which was to build a formulation processing robot. So we got support from the Regional Growth Fund. It's called RGF. And there was an investment of 900k. We'd learned a lot. So now we've got 4 modules, which are all interchangeable and on trolleys. So if a module breaks, it can be wheeled out of the platform and taken away for repair while the rest of the platform's still running. We've got powders, we've got liquid handling, we've got hot liquid handling. So those viscous liquids could be dispensed in a hot state so that they didn't block up the tubes. And we made the formulations in the vessel that they were going to be stored in. So we saved ourselves a lot of effort with cleaning by having the pot being dropped into the formulation module and everything being added to that pot. One thing with the Regional Growth Fund is it wasn't available for Port Sunlight because we weren't an area that was considered in need of development. So we moved across the Mersey River to Liverpool, and we took on a floor of at the time it was being built, IC3 in the Liverpool Science Park. And as it was being built, we were able to adapt it for our needs. So the wall wasn't put in between 2 discrete labs so that Jeff would fit. We moved our Formaxes into the same space and also a whole suite of characterization equipment. This was a very successful facility, enabled us to really move our products formulation, automated formulation characterization on. What do we learn up to 2015? Automation data capture is definitely possible. We now had a large team. I think we were up to about 20 people at this point. Corporate IT challenges were getting very challenging. We were being issued standard desktops that had to be used within Unilever. They weren't supposed to have any extra software installed on them, and we needed a person from IT to come and install the software, which is very challenging when you're trying to configure a robot that's constantly got new updates coming from the suppliers. It's still taking us years to commission platforms, and people and change management were very key factors, although this time we were seeing spontaneous change by the groups in response to the automation we provided. The ambition had increased exponentially from those early small robots. We were now looking at up to £1 million investments, and I think we presented to the Unilever board at least 3 times in this this time period, which was very high visibility of what we were doing, very high stakes. Moving on to current. So following the success of the High Throughput Formulation Centre in the Liverpool Science Park, and also another collaboration that we'd had running with the university for around 10 years by this point that was called the Centre for Materials Discovery, we collaborated with the university and the higher education funding to build a new building called the Materials Innovation Factory. This is attached to the chemistry department at the University of Liverpool. I think the investment is up to £86 million now. On the ground floor, there's an open access area. So we actually donated all the equipment in the High Throughput Formulation Centre to that open access area because it's kit that's suitable for many things other than just Unilever's consumer products. So any company can buy tokens and come in and use that equipment. There's an expert team to run it. The first floor is the floor that we lease for Unilever privately, and that's where we've put all our performance measurement robots. So Christine and Lisa Marie that I showed you earlier. And then the top 2 floors are the chemistry department from the university. The ambition of the building is to bring computer-aided material science to the fore. So we're all well aware of how computer-aided modeling has revolutionized many other industries, but chemistry, certainly in 2015, was still quite behind. So the university is looking to blur the line between the digital and physical R&D and provide that shared infrastructure that's on the open access floor with a dedicated staff to train and run the equipment. So there's experts available to anybody who wants to do that. And also using virtual reality to design new platform and visualize the results. There's a huge VR cave in the MIF. There's also 2 VR setups in on our floor. These proved invaluable for those bespoke builds where we were building robots that no one had ever seen before, and we wanted our scientists to be able to touch and feel them as soon as possible. So we got the CAD drawings into the VR, and they were able to walk around their new robots and very quickly identify ergonomic issues that we hadn't seen or things that could be done better. So we did a lot of in silico design before we actually started cutting metal, and the VR paid for itself many times over through that process. If we look at the university's vision of science, it's very similar to our virtuous circle, but now, as well as the brain doing the define, we've got artificial intelligence augmenting it. We get that design, we can go through in silico modeling, we come up with the design of experiment, and then we go onto the OAA or our floor, we do the make and measure, and we get a new product out. All of that is driven by a consistent data management process. It happens to be the same process that, or the same system that we have in Unilever. So we licensed our Flex system to the university. So whereas we had flow, they have formulations, we had experiment management system, they've got experiments. On the interface to the equipment, there's some harmony. They also use links for limbs. And where we're using Pipeline Pilot, they use the open source 9. But the setup is essentially the same. If someone comes into the open access area, they will be logging into a Flex system from Unilever or the Flex system from the university hosted on their servers. I'm going to take a break from talking. My colleague Mark Orty made this great video, so I'm just going to play you a video about DEFT, which is our digitally enabled formulation toolset. PDAs have got a bit bigger now. They're onto tablets. Still very busy bench though, with the computer on there. So what we see with DEFT is really the closing of the circle. So we started with bench formulation. We then went on to building data management systems around complex automation, big platforms. But we had to validate against the bench scientist, and we realized that the data capture that they were getting was nowhere near as robust as the data capture we were getting. So again, my colleague Mark Horty came up with the idea of the digitally enabled formulation toolset. This is now a commercialized product from our partners, Applied Scientific Technologies, and yeah, it's enabled you to capture what a scientist is actually doing at their bench. Many of our insights are serendipitous, so particularly with our complex, as we take water out of products, the structuring gets far more important. And sometimes people make the perfect product, but they could never tell you why. And it might be because it stirred for 2 hours because they went for lunch, whereas it was only supposed to be stirring for 20 minutes. With DEFT, all of that is captured. All of that processing, as you saw, is fully I can't say it. You can interrogate it and get those insights on what was different about that formulation that gave the much better structure. So what was the same? Well, yeah, automation and data capture is still possible, but now we're looking at outsourced teams to maintain it. So within the Materials Innovation Factory, many of our partners have offices now, likes of LabMan, ChemSpeed. They actually have engineers based full time in the Materials Innovation Factory. So servicing equipment has become a lot more seamless. IT challenges. We're now on a satellite location, so the university are providing us with a network. Unilever IT knows nothing about it, and yet we're still running equipment that is trying to talk to the Unilever network. So very different set of conversations, but still very challenging. Platforms are still taking years to commission. People and change management factors are still key. We've now changed site. People have got to cross the River Mersey to get to to run their experiment. A lot more planning is needed. And that's really magnified how we need to bring people on the journey. We've seen a huge increase in collaboration. Moving to the university, a step change in the number of research groups that we're interacting with, but also the number of students that we're bringing through our lab, from undergraduates all the way through to PhDs. The ambition is focused now, so we've done big. We now understand where we can really add value. And projects have a strong life outside Unilever. So we've seen both DEFT and the Flex data management system going to other organizations to exploit. We've also found that standardization is great. So having a single data management system to run all the robots, but if that data management system isn't available when you want to start a run, you can't run any robots in the MIF. So it's become far more critical that we have good uptime. The robots are resilient once they've started, but you do need to be able to get them started. So looking slightly forward to the future, we've looked at having thousands of manual experiments being done each year, and we've got perhaps 10 platforms, multi-million investment in large robotic platforms, very little in the cobot space. We're looking to flip that triangle and use loose integration and cobots to do those manual repetitive experiments. So the large robotic platform is mature now. We won't be building any more of those, but we see the opportunity to have lots of these cobots doing simple assays. So the one in the video here is in our laboratory in the Materials Innovation Factory, and it's doing a pH measurement. the cobot uses the 2D barcode to orientate itself as it moves around the laboratory, and so it knows where all the stations are. See there, it picked up the tube, it's done the pH measurement, or it's about to do the pH measurement, and then it will go away, pour it down the sink, and that's it. It's done its measurement. So they're very versatile. Still a huge amount of learning. Having a robot walking around the laboratory, even the 2D barcode, it turns out if it stops about 5 millimeters too far to the right, it can see the barcode, but it still can't reach the left-hand side of the deck, which is our challenge of the week, to get its positioning a little bit more accurate. And of course, cobots can keep going when the scientist's gone home and finish the job when it's finished, rather than when the lab has to be emptied. So what's the difference between a cobot and an industrial robot? Well, the industrial robots, they're those big platforms. They're very heavy. They've got high payloads. They've got high speed. If they hit you, it's really going to hurt. The friction rig was carrying around 1 kilo weights at 4 meters per second. If it let go of it, it was a good job there was a perspex screen between us and the robot. We move through cooperative robots. So we have a dolly robot, which does laundry on a slightly larger scale. They're still high speed, high payload, but the robot will slow down if humans approach the work cell, and they will stop if you enter. So on the dolly system, we can actually open the doors. The last stage is to sort the fabric and lay it flat to go onto a measurement station. That's very challenging for a robot arm. So we can actually open that door. The robot will, if the robot's in that space, it will stop, or it will slow down coming towards that space. So we can help the robot sort the fabric and keep the run going seamlessly without having to stop the entire platform and restart it. Moving on from that, we have collaborative robots. So these are much slower speeds. They've got no pinch points and rounded joints. So if they did hit you, they wouldn't do too much damage. They've got collision detection. So if they do hit you, they will stop. And they can be used with humans. So the sort of workflow foundations, we've got these cobots. Potentially they can do anything. Picking the right assays is absolutely critical to make sure that we get value from them. So we need to make sure that the whole assay is actually codable for automation. It needs to be able to cope with the nuances of what the scientist was doing. So pouring is a particularly, or shaking, very dexterous arms can do that far more motions than the cobot can do. And we need to make sure that we're doing the right formulation and performance measurements. We're not just moving the bottleneck. And then we need to work out how the human is actually going to interact with the cobot. Is it going to hand over, or are they going to work together in the same space? All the cobots and all the assays we do, however, have a set of fundamental core activities that we need to get right. Safety being the main one. We've now got a cobot interacting with the world around it. We've got that situational awareness it needs to have of where the humans are. It needs to be interacting with the laboratory management systems. It needs to be interacting with the equipment that it actually wants to do the measurements on. So it's got to have some decision-making intelligence. It needs to be prioritizing and scheduling the work it's going to do. And most importantly, it needs to be able to react to error or unexpected event. I mean, the simplistic rule says if something happens, it just stops. Say the fire alarm goes off and it was halfway through a fire door, it obviously can't just stop there. It's going to keep the door open. If it's in a corridor during a fire alarm, it might potentially be blocking the access route. So there's a lot of intelligence that needs to be built in. And most of this needs to be planned up front. So we've been using systems theoretical process analysis to help us understand the way the robot's going to interact in our lab. So with STPA, you define a system boundary. You actually model the activities that are going to take place within that system, and then you can look at all of the interactions and identify unsafe control actions, and then what loss scenarios they might cause, and then how you can mitigate them. A simple STPA model is the user tells the integration software to start. That tells the instrument to do a measurement. The instrument sends back its status and some data. It iterates till it's finished, and it tells the user its status and what the data was that it's just captured. Of course, that's simple. When we start looking at our laboratory, we've got multiple workflows that are running. We've got multiple pieces of equipment that the workflows are being used on. And so the model starts getting very complicated very quickly. Again, Mark Orty disappeared for a week and produced this. Each of these drills down into further layers, and it's hellishly complicated. But using STPA, we've been able to do a lot of this thinking up front and rigorously research every aspect of the robot. So far, we've come up with 100 or 700 risk factors that we need to look at. Unsurprisingly, most of them are around the cobot actually moving around in the laboratory space, but also a lot around the project, because we've not done this before. So we've still got a lot of project risks, as well as the whole suite of other risks around the platform. And each of those are being investigated and mitigated to make sure our robots or cobots are safe. I don't know if anyone is familiar with the UK. We have a company called Ocado who make they do shopping, automated shopping. So instead of having people walking around supermarket shelves doing pickup for home delivery, they have up to 2,000 cobots on a track running around doing the shopping. 2 years ago, there was a £100 million loss when the cobots arced at their charging station in the roof space of this huge warehouse, and they started a fire. There were some human issues that the fire wasn't identified and wasn't handled in the early phase. So I don't think the fire brigade arrived till an hour after the fire had initially started. But they couldn't get to the charging stations because it was built for robots. It wasn't built for humans, and they had to cut through the roof to try and get into this area, and raised a lot of questions around how cobots, how automation and humans interact, particularly around those areas. They had another fire 2 weeks ago where 3 of their cobots, an antenna fell off one of the cobots, and they run around on tracks with 5mm clearance. It hit another one, it stopped. It wasn't a handled action, and they had another fire, but this time their safety processes worked fine, and they had minimal loss from that. So moving on to standards, I realise I've gone over my time. We talked about EMS. So since 2003, the structured ingest structure of data of results hasn't changed at all. On the platforms, I skipped this slide earlier. I said that when you walk up to any of our automation platforms, you're presented with a common interface. In this case, it's Harmony from Peak Analysis and Automation. You press the big green button, you type in your experiment ID from EMS, and Harmony will guide you through, telling you what to load onto the robot to make that assay run. Behind the scenes, we've got Overlord, which has over 400 drivers for different instruments. So you can drag and drop the drivers onto the workflow, and Overlord will drive that robot through to conclusion. One of the components is the EMS API, so it can upload the results back to EMS. Moving on, we've seen Sealer a couple of times in the presentation. So Sealer is a standardized connectivity system. We can use analytical markup language for transferring the data. What does it mean for us? Every device can be configured to have a Sealer interface, which means it can present its features, and then the client can call those features. This makes them very easily discoverable and generic way of communicating, and particularly if we're using animal as the formatted data standard, it makes building those workflows very straightforward. If we look at our laboratory, I've grayed out the names here, but we have a LIMS system. We have a number of ways to talk into the LIMS system. We have a number of ways of interacting with our robots. We've got multiple high-level control instruments, and then we've got the low-level control instruments. Each of these has an interface. They've all been built. If we stick a cobot in there, and with Sealer, that's seamless because it's they're all talking the same language. If that had been done on peer-to-peer integration, we'd now have to go and rewrite all of those interfaces. So Sealer is absolutely critical to our ambition. We've seen on Deft, all the devices talking to Deft are Sealer, so it's very easy to add new devices. And also that cobot laboratory I showed you is working on Sealer. And we plan to use it for all of our instrumentation on the ground so that cobots could interact with any of our equipment. So every instrument that we're commissioning at the moment will have a Sealer interface. Looking forward, the potential formulation space is vast. I couldn't get to the end of a talk without talking about artificial intelligence. Due to the constant changing environment with sustainability, safety, and currently huge cost pressure on Unilever, doing a full factorial design of our space isn't possible. So we need other approaches. I mentioned AI. It's obviously not the first time we've done AI. Back in 2010, we had a very successful campaign using genetic algorithms in closed loop experimentation to identify lead natural biocides. And
Okay, Andrew, you just got muted, I believe.
am I back again?
Yes.
Sorry. That was a video, did that? So he's got a paper just published in Nature showing how he was able to do more than 600 experiments in one campaign and get to 6 times more active photocatalysts. With hindsight, he says it would be possible to know that they would work, but to actually see that without doing the experiment, they probably wouldn't have found it. So we're looking to harness that, and both of us, he recognises as well, his data management is in need of a revamp. So we have a joint project with the university called Flex 2.0, which is looking to move away from that very structured Oracle database with batch processing to the concept of event cloud, where all those devices, they're all sending their data into the cloud. We've got the IoT, we've got the telemetry, we've got the business systems, building analysis systems, all sending their data in. And now we're looking at tools like Neo4j's Graph, the types of tools used by Twitter to understand how those clouds come together to give us new insights.
Okay, we have 10 more minutes.
Okay, I'm on my last slide anyway, so
okay,
2 slides to go. Just a quick plug. As part of that, I've got a call out for a PhD student next week. It closes. So I've been looking at ontologies for a long time, and there's many ontologies out there in the scientific space. But we found that when you start trying to put them together, particularly for autonomous formulation in our space, there isn't a sufficient ontology to enable a cobot to understand its environment. So I have a proposal with Valentina Tammer, the computer science school in Liverpool University, to actually get a PhD to look at just that space and get us the ontology so that AI and those cobots can all, the same way that Sealer helps the instruments interact, help the whole laboratory understand itself. So future gazing, automation, data capture still possible. Now we're looking at a very collaborative effort to bring that together. Corporate IT, we're now on a satellite site, but all of the on-prem data centers are being removed. So we're now trying to move to the cloud, trying to get robots to talk to systems that are in the cloud through all the firewalls, particularly when they're not on Unilever's premises. Very challenging. The cobots are taking years to commission, although the timeline is a lot shorter than the previous ones around all that safety and all the unknowns. People and change management, the cobots are planned to go global next year. So we've now moved from that co-location of engineers with our robots to the robot being halfway around the world from the person that built it and designed it and is trying to maintain it. So that's really magnified the importance of having the right people on the ground to understand how to run their cobots. What's different? I've seen a huge amount of commoditization. So while the Flex system was cutting edge in 2003, what it does now is pretty standard. Our bespoke automation, a lot of that is now available off the shelf. So corporate IT systems are now mainstream. We're moving away from Flex as our core data management process for our new building import Sunlight to the mainstream IT systems. We found that standards can help, but it needs to be cohesive. So having a standard in one place and not another doesn't necessarily move you forward, and they can just move the pain point. I think for many, many years, we've looked at pharma as our source of IT and data, and that's really turned on its head now. The sorts of tools that are available from social media are really changing our thinking on how data can be handled. And also industries that we look to interact with. There's a lot of more insight coming from factories, so Rolls-Royce, the British Aerospace, Airbus Industries, people like that who are quite close to us. They're doing a lot of digitization of factories, Industry 4.0, IoT, that type of thing is coming from many different places now. And that was my last slide. So thank you for listening. Does anyone have any questions?
So, thank you very much, Andy. I think it was really, really impressive, and I enjoyed a lot your presentation. And I think many of the things I also went through personally myself, so especially the earlier slides that you were showing. And it's actually very impressive where Unilever is moving to. And I actually do very much like the aspect that you look at the, let's say, the automation challenge also very much from a, let's say, human perspective, maybe rather than a technical perspective only, and thinking to like, how can you actually work on collaborative models? I don't mean only the collaborative robots, but also like, so this loosely coupling of different things, but making them able to talk to each other. I like that very much. And yeah, I think we do have another few minutes or so, if you will, to ask questions. So please raise your hand or just speak up. I mean, if it's just quiet, just feel free to speak up and ask questions, as long as Andy's here. Nobody?
Yeah.
Oh, yeah.
I'll put it into the chat.
Yeah. We can maybe also add that afterwards, Christian, to the post when we share the recording, because I think as soon as you leave the meeting, you will also be removed from the chat by Microsoft Teams. So,
okay.
So that you have the link available afterwards. Yeah. I was just wondering, I mean, you mentioned specifically CELA, animal and standards, and I mean, you know that I have a specific, of course, stake into this topic from my let's say bio, but what I experienced in the last couple of years is that. Of course, talking about going digital, integrating your labs, these standards are vital and it's kind of a necessary precondition, but it's not a sufficient one, right? And so what would you recommend maybe to others? As I often hear that, okay, let's go for such a standard, where can I buy it? And the thing is, you can't really buy these standards, right? These standards need to be supported by the various parties you integrate, etc. So what's your experience, or what would be your advice with that respect?
So yes, absolutely. As you saw from that cobot example, if we are if we're going to have that loose dynamic integration, then having a simple way to talk to a whole raft of instruments is absolutely key. We're finding at the moment with people like AST, they started the journey. Excuse me, I'm about to sneeze. They started the journey with us. So as they came, I mean, Applied Scientific Technologies is only about 4 years old. So they have a parent company, Applied Integration, that has been doing work for many years. But they joined the laboratory space and immediately saw from their background that it wasn't an ideal space, and that connectivity was a real challenge. So they were very quick to adopt CELA, and they're writing their own CELA drivers to that equipment. So as new equipment comes into DEFT, it's very simple to plug in. But also they have a collaborative robot platform called the Hive. So moving from DEFT to Hive is totally seamless for them because they're using CELA. So they've seen that. The market is still at that quite immature stage. So it is the integrators who are writing the drivers. It would be great if companies were coming up with them on the core equipment. we've got lots of people that are interested in doing that, and I think with someone like Unilever standing up and saying we are not going to commission an instrument unless it has a sealer driver on it is really starting to change the conversation. We've had EMS, we've had our own common interface for many years. It's great to be able to move now to something which is an international standard. It's much easier to talk about it. It's not just us saying, well, this is our EMS results ingest XML. This is the XSD you need to comply with. Now we're saying this is animal, and as we've seen recently, other people have done work in this space. So there's a Rio ML based on animal, which makes the barrier to entry for doing our rheology stability testing much lower, because someone over 10 years ago did all the work in this space, and we can just adopt that rather than having to go there and say, right, let's work out what to do ourselves. So I kept saying it takes years to build platforms. Business is no longer willing to give us years to deliver. So reducing the barrier on interfacing is absolutely key. And also on the other side, into the data management system, we do have a sealer interface into our Flex system, which we use for DEFT and the cobots. Moving, I may have said, we're moving away from Flex as a core system in the home laboratory. So Port Sunlight is moving to the corporate LIMS, which is rolled out globally. We're keeping Flex for our customized automation. So with a sealer interface to both of those, switching data management systems is going to be hopefully seamless. Whereas looking at the traditional way of doing it is extremely challenging. And also the LIMS system that we have, the traditional way of uploading data it's the drop a file. In our case, it's into SharePoint. It's got to be in the right format. Both systems have got to be able to see the SharePoint site, which is no mean feat. So moving to Sealer, and using the animal format, that's a straight through, no files touching disks, much more transparent handshake. So we're really excited about this, and we think so we're actually opening a new lab next year in Port Sunlight. So that will be using the LIMS system and all the equipment going in there. Possibly not on day one, but certainly the stability equipment is planned to have Sealer as the interface, and that will be our exemplar. And from there, what we're doing in Materials Innovation Factory, and we've been doing for a number of years, will be going from that as a springboard to Unilever globally. So it feels like certainly Unilever is at that point. We've been talking about it for a long time. We're now putting our money where our mouth is, and the company is behind us because it's realized that if it doesn't do it, we look at the timelines to doing the traditional integrations, it just doesn't match what the business needs.
Okay. Cool. It's very, very interesting. Thanks for these insights. Do you have any additional thoughts or questions from the audience?
Andy, it's okay. You talked about change management being key, and I've witnessed this myself, and I do it at the moment, not anymore in lab at the moment. But how do you manage that in a lab? Do you use business users as change champions? How do you do it actually, really? Because it's people, right?
So could you get any close to your microphone? I can't quite hear.
You said key. Change management is key.
Yes.
In these things, because it's about people, right? How do you do it then with people? It's not technology. This is the other factor of introducing these things, automation. How do you do it? Do you have change champions in the lab, or how do you do it? How do you organize it?
So, yeah, I mean, as Daniel picked up, I've put people front and center rather than technology in this presentation, because that's what it comes down to. The technology is never going to change the way the laboratory works if the scientists don't come with us on the journey. So introducing them to the automation as soon as possible, having them in the early phase of the user requirement specification, so they feel some ownership of the equipment. Doing the VR was hugely important in building the expectation and understanding of what was going to be delivered, having them very involved in redesigning their lab space to include the automation. and then having a lot of support for them when it goes live. It's also picking the right people. There's some groups where you just know a robot is going to land and be very successful, and there's other groups where you can see it's going to be a challenge. Working with the higher levels of the organization, mixing and matching those people so that we have digital champions who have come from a background and understand the technology, and sort of reduce that level of fear in a group. If you go to a group that's just got no experience whatsoever with no one in there, it's very challenging. So we can do some people projects organization so that we have a digital champion that suddenly reduces that fear and can calm nerves much quicker than the sort of formal meetings. So having people in those teams was key.
Okay, so you really use change champions, people which are open to it and have a background. Okay, that's what we do here as well.
Early adopters have been absolutely key. I mean, the Materials Innovation Factory was a voluntary process to start with. So people that were coming across the water were going there voluntarily, and that sort of, once that was embedded, their colleagues started coming over, and there was already a group of people in Materials Innovation Factory that were completely comfortable in the building and welcoming, and helped them get settled.
Okay, good. Thanks for sharing this experience.
Also reorganizing the support structure so that if you do it using automation, you get third parties coming in to help you with the logistics and everything. So one of the big barriers to entry of recording your formulation was that if the materials that you were trying to put in it weren't in the data management system, you had a huge overhead to go through and register all your materials. So, gosh, it must be 2009. We used our laboratory management services, which happened to be Sodexo at the time. They would register every material that was delivered on site. So every scientist had no excuse of not scanning the barcode on the bottle because there wasn't a barcode, because we ensured that every bottle had a barcode on before it got to their laboratory. And when they went to the flow system to make their formulation, everything was registered. So all they had to do was put it together. And again, with DEF, that's absolutely critical, because if they can't scan the barcode, DEF doesn't, well, you can type it in manually, but obviously that loses the history very quickly.
Yeah, this is clear. Okay, thanks.
See a question in the chat there. Where do we keep our raw data during the journey? So on the Tecan Genesis platform at the start, I was using Excel. I think I said there was 500,000 data points. It was Excel 95. It had 256 columns, and 32,000 rows. So I filled a spreadsheet. I then tried to create another worksheet. I used up all the memory in the computer. I completely corrupted it. I lost my data set at least 3 times. And so in 2003, there was 1.5 of us in the in the high throughput team at the time, because my boss was 50% on Insight Faraday. We had an extra headcount for one more person, so we had a full-time person from Tesela, a guy called Richard Stone, who sat behind me, and he did the coding while I said what I needed. So we wrote EMS over that year with him full-time on the project. And as I say, the code is still, that core code is still running today. So the user interface is still the same. It is changing, hence Flex 2.0. It's a bit scary now, but yeah, that system, the Oracle database behind it, hasn't changed at all since 2003. So it's been able to take everything from a 96 microplate that it was designed for through to a human body. So we can change the plate layout to be anything, and then say the location of an armpit, you can put your deodorant in the armpit, you can put the bugs in the armpit, you can take the malodor scores from the armpit. It's been remarkably resilient to things we've asked it to do. There's still Excel. As I said, we've sorted out the raw data capture. We have all the raw data stored in the Oracle database, but we still have to do an export. And the main button in the pipeline pilot endpoint is the "and export to Excel." And that's where ELN comes in as well. I talked about in the triangle, you've got that very structured hierarchy, but then when it gets to the context of what that result means to your project, that's not standardizable. So that's where the scientists still use Excel, PowerPoint to explain the results in the context of their assay. But because we've got that core structured data, we can also use their results for modeling, and we've got all the metadata to make that possible. next generation Flex 2.0, yeah, I mean, it's I think the penny dropped when someone said, if you lose your Oracle database, all you need to get back is the log of what happened, because from the log of what happened, you can rebuild the database, because it tells you everything that went in and everything that went out. So actually, why do you need the database? Because that log is all you need. And if you start using the tools, Twitter has a whole range of tools for understanding and interpreting completely different data coming in. So it makes it very exciting and much easier to visualize how your telemetry stream, your IoT sensor stream, you've got the traditional instrument stream, we've got the data streams all coming together, and not trying to build a structure to hold those is quite comforting to me, because it's challenging.
But I mean, if I remember, so my past life, usually companies were also building their own bespoke systems and their own whatever non-standardized interfaces and solutions, because there was no will to actually share anything with competitors, etc. Do you also see a change that actually towards more openness and like say, okay, let's go and share? For instance, you mentioned common data formats, common TILA features or whatever, so to actually profit from work others have been done, while as usually, in my opinion, there is anyway no IP whatsoever in it, in these things, right? But still, companies tended, at least in the past, not to open up. Do you see a tendency towards like going more open? I mean, mentioning Twitter, social media and stuff, and cloud tools.
Yeah, I think Unilever's been quite forward in that space, because we've fast-moving consumer goods have never been a core market for the vendors. So we've been borrowing heavily from pharma for many years, and that Insight Faraday partnership way back in 2003, that was across Syngenta. So the agricultural, I think there was aerospace in there. There was car manufacturers in there, as well as the pharma companies. So we've always been looking to take ideas from other industries, because no one was developing them specifically for us. I think when I told Molecular Devices I was putting a ceramic tile in their plate reader, they were quite shocked. But if you do a 384 well scan of a ceramic tile, you can get the fluorescent spots very high resolution compared to a scanner. So they had to redesign a clip for us to hold our ceramic tile, but vendors were very up for that sort of thing. Going forward, we're at a sort of change point. As I said, our corporate systems have caught up, so they're commoditized now. The main laboratory we're running on the big, I sort of describe them as the super tanker systems. They're not going to change very fast. Materials Innovation Factory, we're sort of splitting away from that and leapfrogging again with Flex 2.0. The fact we've licensed our whole data management suite to the university to provide to anybody who comes into the MIF open access area. Unilever is very open in this space, and yeah, we'll happily steal with pride where people have already written Sealer drivers, and equally our plan is to make the drivers that we're writing available. So I know AST are in the Sealer consortium. I don't know exactly what they're doing with their Sealer. I know they advertise them. I'm not sure whether they're selling them or making them open source. But we're happy to share.
Okay, that's excellent. That's also what I personally believe, that this is a big plus, and actually what is making, for instance, a standard like Sealer quite interesting is this open community and actually sharing stuff, which is actually not maybe the type of work where you actually do have your IP in, right?
Yeah. I mean, getting clearance for this talk, which I got at 6:15 last night in the end. Yeah, it's very clear how we're doing it is not Unilever's core. That's not our IP. It's what we put in bottles, which is what we sell, not IT solutions. So we're happy to talk about how we do it and collaborate where possible to make that happen. There's various vendors that we have conversations with, and they're sort of saying we're under NDA with both of you, and so going to joint development agreements so that we can just open up those conversations just makes life so much easier. Of course, it's getting over that NDA step where they can't tell us that they have someone else working with them because that's against the NDA. So sometimes there just needs to be some conversations just to sort of unlock that.
Okay. Excellent. Thank you very much. I mean, we are at the end of the foreseen time slot. Are there any final question or so?
Yeah, this is Burkhard. I have a question. So first of all, thanks for the excellent talk. Very enlightening. I'd like to touch on the question of business justification for using standards, right? Because I think we all agree that standards are a great concept theoretically and politically, and it's pre-competitive collaboration and so on. But then there is always the alternative of solving the same problem in a proprietary way. By hard coding it, by just having something custom created by the vendor or by an integrator. Have you looked at this from a business case perspective, so that you can actually argue, oh, doing it with the standard is actually cheaper, more sustainable, and so on. So it touches on certain of the attributes or endpoints that are important to you. In order to make your business justification for a given project?
Yes, I think that's really coming into the spotlight at the moment. So, as I say, we've got Sealer on Deft. It's been pretty behind the scenes. It just works. So we're enlightened by it. I think the Port Sunlight moving to a new laboratory and saying all the equipment going into that laboratory needs to be cobot ready. It needs to have a Sealer interface. That's where the more senior management is really beginning to understand now that, well, the project plan for additional integration to the LIMS system was like 2 or 3 years. Hopefully our timeline for doing the Sealer integration isn't going to be the same, because once we've done one, the LIMS side of it is basically complete. The LIMS will present the rheology features that what it needs from a rheometer. The rheometers will present the data through the animal using their Sealer interface, and that will just open that whole area. So that story is very is understood. Getting that delivered and having that as exemplar, I think, will really accelerate the uptake. But I mean, that slide with the cobot being dropped into the middle, I think that's the one that has really caught the imagination of the managers, because they can see all those lines, and they kind of have a picture in their head of how all those lines work. And when you pull it apart and put another block in the middle to rewrite all those interfaces, it's scary. With Sealer, that's pretty seamless. So that certainly caught the imagination, and there's no one pushing back on us saying that we shouldn't be doing this. They just want it yesterday, of course.
Okay, thank you.
Okay, excellent. Then I would say thank you again very much, Andrew, for your presentation, and the insights in your journey is really very, very interesting. Also for me, very enlightening. And yeah, thank you all the participants for joining the session. As Christian highlighted at the beginning, the recording and everything will be made available. And I guess, Christian, you're going to send around a mail, and it probably will also be published on social media or LinkedIn, etc. Yeah, thanks again. And for all of you, have a great rest of the day. And hope to talk to you again soon. Thank you.
Thank you.